Hello folks, welcome back to Model 3 Drive Unit Madness, and we finally got a bit of a update for you on this particular process, long as it has been. So what I have here is the second 3D printed prototype logic board, which a chap in Germany has been doing for me very kindly. And this basically let me do the changes that we'd found on the last one of these, which included mainly the high voltage interlock connection here on the main DC connector. So everything else is pretty much fitting where it should be. One or two little tweaks, I think, on this guy here, and there's a peg here that needed a tweak, but everything else sits in there. The pins for the transistors and all come up through the holes, the DC bus connections, all that. So everything is pretty much, probably not 100%, but like 99 at this stage. So based on, as the saying goes, the strength of that, I decided to bite the bullet and tidy up the PCB and order some prototype boards. So this is what we have in the blue package here. So let's move this over here. So some of you may know from my recent postings on Patreon and that I've been a little bit distracted by a CNC plasma cutter project, but in the meantime we had these boards ordered, and thank you very much to following my last video on the 3D printed one. A lot of you sent me money for this project, so thank you very much. I wasn't expecting that. You folks are way too good to me. But basically what we should have in here now, just arrived this morning from JLC, not sponsored or supported by them, by the way, in any way. We should have two reasonably completed boards. There's some components obviously they don't have that we've got from Mauser here, and there should be then three just bare boards, because I ordered 5 boards and I got 2 of them assembled. So without further blabbering, this guy up here, I suppose let's tear into this thing. Let's make sure this thing is actually filming and not just making a monkey out of me, which is entirely feasible. So Johannes style unboxing inbound. So just one last thing, I was doing a little bit of a tidy up here this morning. I came upon this guy, which some of you may recognize. That's the large drive unit logic board. That's actually a hand soldered prototype. It's the one that I had in the Panzer for quite a few years since the recent upgrade. So we've from this to this, I guess. So yeah, let's see what happens. Oh wow, I think they've put 2 boxes together, I think, by the looks of it. So yeah, let's open this up. There we go. So all in here, including paying import taxes and all that, we've got about 600 euros in these prototypes. So as I said, you know, it wasn't an easy decision to make to go for this, but thank you so much to everyone. All right, here we go. Let's get rid of that. This is it, folks. First potentially working prototypes. Of course they won't really work, but you know, kind of feels good to say that it's potentially working, not really working. I'd say we'll have a few iterations of this design somehow. But I think, and again, you know, feel free to correct me here if I'm wrong, because I do have my Doing It Wrong t-shirt. I think this is the only attempt at making a replacement board for the Model 3 drive unit, so might be a world first. Oh, I'm beginning to see shapes. Still shapes. There's something coming out. As the saying goes, OMG, folks. OMG, there it is. It's an actual, well, you can see that, hopefully with my terrible camera work. That is an actual PCB. Yeah, with all the planes in it and all of the, wow. Yeah, sorry, I know this is probably making terrible video and all that, but yeah, it's kind of giving me pause. All right, that's enough pause. So, first things first, we'll take one of the bare boards and we will take our drive unit inverter, which is currently only got the 3D printed one on there. Pop that off and let's see how dreadfully that this one lines up. Oh, this one lines up pretty darn well. I'm not gonna force anything at the minute. These pegs are lining up. Holes are looking good. I think this peg up here is probably a little bit small still. But yeah, it's it's definitely, I think, good enough for a test. But yeah, wow. Yeah, okay, stop looking, Damien. Okay, so I think we should be good to go. So let's get out what you've been waiting for. So you have to fast forward all of that previous junk and see what I have in terms of. Oh, there's the other bare boards, so we'll pop those over there. So in here now, in the finest reaches of, woo, Elon, you madman, we've got our live one. Man, probably can't see any of that. There it is. All right, let's have a very quick look-see here at how it kind of looks. I think it's going to fit. We've got our, yeah, DC positives are lining up here. And oh yeah, the board just fell down onto the transistors there now. This one's going to be a little bit of a problem. That hole there is a tiny bit off. There's various other little tweaks, but there it is, folks. Okay, so this is going to be a first power up attempt, just applying 12 volts. Theoretically, what should happen is that the 5 volt and the 3 volts logic power supplies should power up and give us an LED. Obviously we don't have the gate drive transformer and parts of the feedback circuit fitted, so that's fine. That won't do anything. But this is the part where I find out whether I've screwed up real bad to the point that this is complete scrap, or whether we have a chance. So we have a chance. We're drawing 30 milliamps. Okay, that is good. Oh, boy, oh boy. Okay then, let's probe around here and see what's working and what isn't on the power supply section. So we got grounds on all of these guys. Just checked that my meter works. Oh yeah, my meter. Nope, my meter is not actually working. That's great. These should be all on ground. That's very helpful, meter. Thank you very much. Hey, no problem, Damien. It said. Yeah, these should be all on ground. Why am I not seeing? Great. Fun in the sun. Maybe they're not all. Maybe I actually haven't got them connected to ground. So that's not very clever, Damien, is it? No, it is not. Okay, that one should be ground. It should be clock. Our clock ground data. So we should have here on our SWD port. Aha. Yay. Okay. Bingo. All right. So I have some capacitors here on our power supply section. So if I probe around here, we might be able to see if we have any volts. Something's happening. 3.2 volts. 3.27 here. So that's good. Oops. At least we don't have the musku, and 5.00. So I know it's a low bar, but we have our two logic level power supplies are working. The next thing to see is, can we communicate with the STM32? So let me grab my programmer, if it wants to play nice with me. Do you want to play nice with me, programmer? Sure, said the programmer, why not? So we're looking at clock, ground, and data. Theoretically, connect that in like that, and go like that, and go connect. Oh, we're talking. Yeah, we have an STM32F103 high density part. We're talking. So let's go ahead and we can pop, let's see if it'll take the CAN loader. Start programming. Yes, it does take the CAN loader. Okay. So also now, theoretically, we should have supplies down here for the logic sides of the gate driver chips. So let's disconnect our programmer. Okay, let's see if we have any power down here where our gate drivers would be getting their logic. So I got my little magnifier, there's my ground. Now, can I remember? That's ground. Oh yeah, there it is. 3.2. Yeah, 3.2 on this one. 3.2 on this one. 3.2 on this one. Yeah, 3.2. 3.2, and finally, is he 6 for 6? 3.2. Now, I suppose the next thing that you're going to want me to do is to flash the activity LED on here. So obviously we don't have software for the Tesla Model 3 drive unit as yet. But what I will do is I'm going to try and load in a little hacky version of my MG code, which runs on the same chip. I did copy a lot of the pinning and so on from the MG logic board. So let's see if we can put that in and just see if it'll actually do anything interesting here. Okay, so I've loaded the MG code in here, which I checked does use the same pin for the LED. So I'm going to hit the power, and theoretically we should see an LED flashing. Okay. The processor is executing code. Okay. Next thing, I gotta get a Wi-Fi module connected and see if we can communicate with our program on here. Okay, so I've hooked up a Wi-Fi module directly to the serial port. Obviously, this won't be how it's done for when it's installed in the drive unit, but I did put a port on the PCB so you can directly connect a Wi-Fi module just with some jumpers. How it'll be done is using one of these CAN-based Wi-Fi adapters that you can put anywhere in the vehicle and connect it to the logic board over CAN, or you can obviously use the open inverter CAN tool that Dave has been working on. So I think the next step here, now that we have the logic side power going to, I think, pretty much everywhere it needs to go to, I'm going to see what I can do about bringing up the gate driver power supply section to see if we can get the isolated gate driver power supplies on. The other thing I want to do is I can just do quickly here now is just to verify that we've got 5-volt supplies down here for the current sensors. It's going to be rather important. Let's see what I've got. Oops, but help if I had some light, wouldn't it? So, okay, so that's going to be a positive there, I'd imagine. Oh yeah, I got 5 volts here. And have I got 5 volts here? Yes, I do. So, okay, so turns out I thought I had most of the bits I needed in from Mauser, but of course I did not. Do have the gate driver chips, so that's pretty good. And I have my little gate driver transformer. But what I don't have are the ACPL M49 optocoupler, most importantly here in the U5 area, that provides the feedback for the PWM generator chip for our gate drive power supply, and less importantly to go in here for controlling our high voltage bus discharge resistors. But I've ordered those bits now, and a couple of diodes as well that I just wasn't able to find on JLC, but now I know a little bit more about them. So like all of these things, it kind of brings in more learning. So I know how much you folks really love my videos for being insanely long, so I'll try and do these in little segments for you, little meaning 30 to 40 minutes probably each. So I'm going to wait till I get the next bits back in now before we fit the rest of our components here and try to power up the gate driver power supply. In the meantime, what I'll do is I'll start getting the software for the microcontroller to the point that we'll be able to switch the gate drive power supply on and off as required, and assuming that works, which is the real if here at the minute, and then if we get our voltages stabilizing here on our high voltage side of the SiC MOSFET driver, I'll fit the chips hopefully in the next episode, and then we will be pretty much good to go to see then if we get some PWM generation. Well, actually I'll probably check with PWM generation as far as here, and then obviously if we get PWM generation here on the outputs, we should be good. So I will cut it here. As I say, we'll see you folks in the next semi-exciting episode. As always, don't forget to give this garbage a big thumbs down. Do check the links in the description for GitHub and Open Inverter Forum, and of course avoiding Patreon and PayPal at all costs, because I just waste your money on these kind of stupid projects. Nobody wants that. But I think until next time then, folks, happy musk board populating.